Okay, welcome back everyone. In this video we're going to look at an example of how to solve a problem using the Doppler effect. So this is actually number 78 on page 502. And so what you have is a fire truck which is racing towards a fire over here. Okay, ignore my drawing. There's a fire. Wait, hold on. Third time's the charm. There we go. Okay, so there's a person standing kind of off to the side of the road, and they hear the frequency of the siren change as the truck whizzes by. Meow. So the original frequency that they hear as it approaches is 476 hertz, and the frequency that they hear when the fire truck is receding is 404 hertz. So this person is actually the observer standing still, and what we want to know is V of the source. And we're given that the speed of the wave is 343. Okay, so our Doppler equation is that the observed frequency is equal to the emitted frequency, or the frequency of the source is probably a better way to write it, times the fraction, the speed of the wave, plus or minus the speed of the observer, over the speed of the wave, minus or plus the speed of the source. And it's this, the speed of the source, that we are trying to find. We already know that the speed of the observer is 0, so that goes away. And so now it's as simple as just plugging and chugging. So here we go. The observed speed is 476 hertz. And wait a second, we don't know the frequency of the source. So we're just going to write that as F. Okay, well maybe that'll be the only thing that we need. So now the speed of the wave is 343. We don't have to do plus or minus. And it's divided by the speed of the wave again. And now we have to decide, are we going to use minus or plus? So remember that if two objects are moving toward one another, we use the top. And if they're moving away from one another, we use the bottom. So we have to use the top, or minus, and then I'll just write the speed of the truck as V. Okay, so that is one equation, two unknowns. Well, thankfully we also have a second frequency. When it recedes, it's 404, and this is the emitted frequency times V wave minus 0 over 343 plus V. Now, why did I use the plus sign? Well, if the fire truck is moving away, it's receding, and so you're going to hear a lower pitch. So the frequency should be less, and we use the bottom, or the plus sign. Okay, so remember that if we are talking about approaching, we're going to have plus and minus, and if we're talking about receding, it's going to be minus and plus. And in both of these cases, I'm doing plus 0 and minus 0 because the observer isn't moving. Okay, so now I have two equations, two variables. It's time to solve for V. Well, we don't want F in there, so let's just divide one equation by the other. So I have 476 over 404 equals, cancel, 343 over 343 minus V divided by 343 over 343 plus V. And this is kind of tricky, but what's going to happen is that the 343 plus V will flip up top, and the 343 minus V will go to the bottom. Okay, so if you don't believe me, just write 1 overs and divide it out the long way. You will see that this is indeed the case. And at this point, we just have a simple equation to solve for V. It's very straightforward. What we get is something along the lines of 24,696, if you want to check your work, is equal to 880 V. So the speed of the fire truck is about 28.1 meters per second. Okay, so that's a three-dot problem. It's not easy, but all we have to do is solve a system, and now we have the speed of the fire truck. Now if we wanted to, we could also go back and find the frequency that the fire truck was emitting, but I don't think they ask us that in this question. Okay, so that's it, and we'll see you next time.